Now we already know how to identify the oxidation states of atoms inside compounds, so this gives us a tool to identify redox reactions. In other words, if in a chemical reaction there is one atom that changes its oxidation state from reactants to products, that is a redox reaction. So just the same example we gave in our previous video, in which there is zinc and copper 2 plus that becomes zinc 2 plus and copper 0. In this case, there is clearly a transfer of electrons. There has to be a transfer of electrons from zinc to copper. And because there's only transfer of electrons, one can necessarily split the overall reaction into two half reactions. That half reaction is the reaction in which there is a loss of electrons, and we call this oxidation from the word oxygen. Typically anything that reacts with oxygen is going to lose electrons. And there is again another half reaction that is gain of electrons, and that we will call reduction. And what's important is that the number of electrons that coming out of the oxidation half reaction have to be equal to the number of electrons needed for the reduction half reaction. So let's practice some more. In this case, zinc is reacting with acid. You can split this redox reaction. First of all, notice that there is a change of oxidation state. The zinc goes from 0 to plus 2. Hydrogen goes from plus to 0. So we can split this reaction into a reaction that is going to lose electrons, plus 2 electrons, and hydrogen is going to gain 2 electrons. These are the two half reactions of the overall, and it's important that one can split the overall redox reaction into the two half reactions. So the oxidation, this is the oxidation half reaction, and this is the reduction half reaction. The oxidation, the reactant loses electrons. We will say that the reactant is oxidized by the what we call oxidizing agent, and the reactant in the oxidation reaction is called the reducing agent. Careful here, because it can get a little bit confusing in terms of the terminology. We'll say that zinc is oxidized, and zinc, because it makes the reduction of hydrogen possible, we will say that zinc is the reducing agent. Okay, and by definition, in an oxidation reaction, the reducing agent will increase its oxidation number. It went from 0 to plus 2. Okay, likewise, in a reduction reaction, in this case hydrogen, will gain electrons to become the element hydrogen. We will say that in this case the proton, right, the H plus, or hydronium if you will, is reduced, and again is the oxidizing agent because it makes possible for zinc to be oxidized, and it will decrease its oxidation number. Careful, because if it decreases, it can go from negative to 0, from positive to 0, from positive to negative. It could be from 0 to negative, or it could be from negative 3 to negative 5. Good luck finding that one, but definitely from plus 5 to plus 3, for example. That would also be a reduction. So it has to decrease its oxidation number. So let's practice a little bit. In this case, we are given a redox reaction that is not balanced and is asking to identify what two half reactions this redox reaction has. So to split it, you may need to split this ionic compound, so we can assume this happens in water, so we can actually safely split it. Cesium will become cesium plus, therefore it releases 1 electron. Notice that the charge on both sides of the reaction has always have to be the same. Matter is conserved. So if the overall charge in here is 1 plus and 1 negative, that makes an overall charge of 0. The overall charge here has to be 0, so we're good. And chlorine becomes chloride, and I need to put 2 here, and notice that for the charge to be equal on both sides, you have to put 2 electrons here. This would be our oxidation, and this will be our reduction half reaction. Okay, so let's see which one corresponds to, I believe it's this one. Okay, notice that to be fair, you would need to multiply this one times 2 so that you get 2 electrons leaving the oxidation reaction and arriving for the reduction reaction. Definitely we will practice more, but the take-home message of this video is that for any redox reaction, you should be able to split into a half reaction for oxidation and a half reaction for reduction.